We're still solving triangles using the law of sines. But now we come up on a case where we've got asked to solve a triangle given two sides and an angle. And this is side-side angle. This is the side-side angle case. And in that situation, we can have one solution, we can have no solutions, or we could even have two possible solutions. In other words, and we call that two possible solutions the ambiguous case. Or ambiguous cases. So, and we've got several steps that we'll have to kind of check through to determine, do we have no solution? Do we have one solution? Could we possibly have two solutions? And then we can set about trying to solve. So here we're given a triangle, we're asked to solve it, and we're going to round any side lengths that we determine to the nearest tenth and any angle measure to the nearest degree. So in triangle RST, angle R is 95, side R, that's the side opposite the angle we know, is 10, and side S is 12. Now, so the angle we know, well, it's obtuse, and so we need to look at this side of the possible triangles in a side-side angle case. And if you look what we're talking about, we're asking the question, is the side opposite the angle we know, is it less than or greater than the additional side, the second side that we know? Well, in this case, the side opposite the angle we know is 10, and the second side is 12, and so we can then say that that side is less than, 10 is less than 12, and so it would fit this scenario right here, which means, in this case, there's no solution. For there to be a solution with an obtuse angle, the side opposite the angle we know has got to be greater than the other side when we're looking at side-side angle. Let's go look at another one. All right, this time we got triangle MNP, which and let me say this, you should always sketch your triangles. They don't have to be drawn to scale, you just got to get something you can visualize. All right, well, we know angle N is 32 degrees, and the side opposite that is 7. And then we know side P, which is 4. Now, we're dealing now with an acute triangle, and so we've got to go through a couple of scenarios. Well, one, we do know that side A, or excuse me, in this case it's side N, is greater than P, and so we should have one solution. But we also need to double check the height, because if the height of the triangle is greater than the side opposite the angle we know, there also could be no solution. And you see here that I drew in this kind of shadowed red line, that represents the height. And drawing that perpendicular to segment NP gives us the right angle. And from there, we can find the height. So we're going to quickly check the height to make sure that the side we know is greater than the height of the triangle. And we know that the sine is opposite over the hypotenuse. And so in this case, where I designated the height would be opposite, and 4, side P, would be the hypotenuse. So we got the sine of 32 equals h, which is the height, over side P. And we substitute in side P, so the sine of 32 is equal to the height divided by 4. And 4 times the sine of 32 equals the height, which equals 2.1, and that is in fact less than 7. And so we've met both parameters of this. The side opposite, the angle we know is greater than the other side. That's a key for one solution. We double check the height. The side we know is greater than the height, and so we're only going to have one solution. Now to find the one solution, I'm first going to find angle P, which is this section right here. So we got the sine of 32 over 7 equals the sine of P over 4. And then therefore 4 times the sine of 32 divided by 7 is going to equal the inverse sine, because I'm trying to find the angle, so I'm going to use the inverse sine function of P. And that's going to equal 17.6, and we're asked to round the angle measures to the nearest degree, and so it's 18. Now, what about finding angle M? Well, there's 180 degrees in a triangle, and we were given that one angle was 32. We have found that the second angle P is 18. So if we take 180 less 32 less 18, that would give us the angle M, which in this case is 130 degrees. Now to find side M. Well, we use what we were given, which is the sine of 32 over the side measure of n, which is 7. And now we've got that's equal to the sine of 130 over m, side m. And when we solve for m, we're going to end up with 7 times the sine of 130 divided by the sine of 32. And so side m is going to be 10.1 units. And so this would be 10.1. And Shazam, we have solved the triangle. You want to keep that chart handy, because in the next video we're going to have one that's got 2 possible solutions. It gets even a little more complicated than this one. If you think that's possible, which you may not, but I hate to tell you, it is.